In our first three examples, we want to take a look at how we can use the properties we just established to expand a given logarithmic statement, writing it as either the sum or difference of logarithms. To do this, in our first example, we have the log base w of 12y times 9d. If we recognize that what we're doing is multiplying together two expressions, 12y and 9d, then we can use the product rule to break this logarithm up into the log base w of 12y. Since we're multiplying those two factors together, this becomes addition. So plus the log base w of 9d. Once we complete that step, though, if we look again at what's inside our logarithms, each of the logarithms that we're left with is again the product of two different expressions or two different factors. So what we can do is apply the product rule for logarithms again to break this up further into the log base w of 12 plus the log base w of y. That's the expansion of that first term. And then the second logarithmic term will be expanded into the log base w of 9 plus the log base w of d. And then we have this original logarithm expanded as much as possible. In example 2, we want to do the same thing, but now we're dividing two expressions. So we'll rewrite this as, or first we can identify those two expressions, 8 and L to the s power. So we'll rewrite this as the natural log of 8. Since that was division, we'll make this subtraction. So we're subtracting the natural log of 11s. And we do have one extra statement in our directions here. We want to rewrite this as the sum or difference of logs explicitly with no exponents, meaning the next thing we need to do is take care of the fact that 11 is being raised to the s power. Nothing will happen to the natural log of 8, that first term, but now we can use the power rule for logarithms and bring that exponent down as a factor in front to rewrite this as s times the natural log of 11. And we have a new statement that's fully expanded, written with no exponents. Example 3 is just a more involved version of those same two types of problems. We have an expression in the numerator and an expression in the denominator. So the first thing we'll do is rewrite this as the natural log of a to the negative first power times d squared minus the natural log of m to the 9th power. We can continue rewriting using those properties. The next thing we might identify is that our first logarithm is the product of two different expressions. So we could expand this out by rewriting this as the natural log of a to the negative first power. Since it's multiplication, we'll use addition to rewrite this as plus the natural log of d squared minus the natural log of m to the 9th. Now the last thing we want is to rewrite this without any exponents. Each of these log terms has an exponent, so we'll use that same property to bring those down as a factor in front. Negative 1 will drop down as a factor in front, so that will make this negative natural log of a plus 2 times the natural log of d minus 9 times the natural log of m.